Today we're going to take all this nonsense that's on my bench and turn it into this. If that sounds like something you'd be interested in, then stick around. So I don't have a benchtop power supply, especially not a dual channel benchtop power supply. But I'm in constant need of a dual rail power supply because I'm usually designing and prototyping circuits that use op amps. So I decided it should be simple to make a dual rail power supply myself with spare parts that I have laying around. But I don't have a center tap transformer. Without a center tap transformer, that becomes a challenge, right? Plus, I don't need a lot of voltage and I don't need a lot of current. I'm not going to be powering amplifier boards, and so I just don't need a whole lot of power. So I've got this wall wart. It's just a simple AC to AC wall wart. It's 9 volts at 1000 milliamp, and I want to be able to make a dual rail power supply from that. So you would think that that would be a simple task. So I did what most people would do. I said, hey Google, how do I do this, right? Figuring that, you were going to have to use half-wave rectifiers or, something like that to get this to work. And what I found out is there's not a whole lot of information out there about this, and what is out there is not necessarily accurate. I did find some useful information out there. I didn't really find just a ready-made, okay, here's how you do this. You would think that that would be something that's quite common. But I found out enough information that I was on the right track, and sometimes that's all you really need is just to know that you're on the right track. And so I just said, well, okay, I'm just going to design this thing on my own. I'm just going to use some of the ideas that I already had and some of the things that I found, and I'm just going to build this. And that's where we're at. But this is what I've come up with. This is my design based on some of the things that I found that, on the internets. And some of it's just my own thought process. But essentially what you've got is an AC 9-volt wall wart that we looked at earlier. And we're going to get out of it, in this case, 15 volts positive, 15 volts negative, and a 0 reference voltage. It's actually it looks a lot more complicated than it really is. So what we got going on, we've got our AC coming in. These are the 2 leads from your AC wall wart. You're going to tap one of them here and bring it down, and that's going to ultimately become our negative rail. The second leg of that AC input is going to be our reference or our 0 voltage throughout. So in this case, I've got a 470 UF 16 volt capacitor here and here. Notice the orientation. This one is leading with the negative, this one is leading with the positive. Keep that in mind. Then you've got your rectification going on both sides here. Then some filtering here before you reach your voltage regulators. And something to keep in mind on this, all 4 of these diodes are 4007s. They're rated at 1 amp, which is plenty for our circuit. If you're pushing more than that, you're going to need more. The value of this capacitor and this capacitor as a pair, and the value of this capacitor and this capacitor as a pair, need to be as close in value as possible. The further they are apart, the more DC ripple you're going to produce before your regulator. The values themselves arguably are not as important as the fact that they're as close in value as you can get them. So if you had a 470 here and only had a 580 to go here, that would probably be okay. Or if you had a 330 here and put a 470 here, that would probably be okay. But don't put a 470 here and then a 2200 here. The rest of the circuit is pretty much straightforward as far as if you've ever used voltage regulators before. Just keep in mind that your positive regulators, your 78 series regulators, the input is pin 1, the ground is pin 2, and the output is pin 3. But on a 7915 or the 79 series, pin 1 is the ground, pin 2 is the input, and pin 3 is the output. Just keep that in mind. It'll save you a whole lot of trouble, trust me. Because if you get them jacked up, you will burn things up, there's no question. Now let's talk about my filtering section over here. I'm going to use 4 2200 UF 25 volt capacitors. 25 volts is plenty on the output because we're regulating it to 15 volts. Are all 4 of these capacitors necessary? I don't know. We're going to find out, maybe. I might try it both ways, but most likely it's probably a little bit of overkill. I'm not looking for lab quality output here, but I do want it to be pretty smooth and pretty clean. If I can and have time in this video, I'm going to hook it up to my scope and see what kind of DC we're getting, see if it's a nice smooth DC. And I think it will be, but theoretically you could probably leave one pair off. I mean, it's up to you, but you know, the more filtering you got, the smoother it should be to a point. And these are just going to be 100 NF ceramic capacitors at the end. If you look at any commercial power supplies or most power supply circuits, they've got these at the very end of the output. And my understanding, and at least as far as my memory is concerned, that is to filter out some high frequency stuff. And is it 100% necessary here? Probably not, but why not? But we're going to put it together here in a minute and find out. Okay, so I finished up soldering the board. I guess it turned out all right. I went ahead and put the jack on for our wall wart. This is going to be our plus 15. This is going to be our negative 15. This is going to be our 0 volt or ground. Turned out pretty good, I guess. I ended up not being able to get my 100 NFs on here. I counted these holes out and I had it down to where they were just going to be perfect. They were going to go in the very last hole. But I noticed that I ended up getting my regulators over one hole too far and I ran out of room. But overall, pretty happy with it. I mean, as long as it's going to work. I haven't really tested it yet. I'm hoping that it's going to work. And of course, I'm going to put all this in a case, and I'm going to end up using probably banana plugs. So I can just plug my probes or plug my alligator clips into it. And then, of course, mount the DC or the AC jack in this case to the box. But anyway, let's plug this sucker in and see what it'll do. I've got the lead for my wall wart right here. So get it plugged in. Everything should be powered up now. Let's get the meter and see what we can see. We should get 15 positive DC volts right here. So 15.13. I'll test this other lead. And 14.94. I didn't really want this to be 15 volts actually. I wanted it to be more probably in the 5 to 9 range for op amps, but that's the only regulator pair I had on hand. In the future, and I may do another video on that, I'm going to probably make this a variable output so I can get 5 to 15 out of it. It'd be much more useful that way. At the very least, I'm going to make it 9 and 5 and switchable, so you could switch back and forth between the two. So I got this little handheld oscilloscope that I got off of Amazon. It's not the greatest scope in the world, but it is kind of useful for some pretty basic stuff. And so I've got it hooked up right now on the negative voltage rail, and it's showing negative 15 volts. Pretty damn smooth DC signal. If it was a terribly ripply DC output, you would see some distortion in this. I mean, I hope you can see that screen. I know it's probably hard to tell. But it looks pretty damn good to me. I mean, I'm not going to complain. So anyway, in conclusion, I guess, we got ourselves a low voltage, low current dual rail power supply for testing op amps and for prototyping op amps and things like that. Overall, I'm pretty satisfied with it. So anyway, I hope you found this helpful. If you did, hit that like button and subscribe. I'd appreciate it. And if not, well, I guess I'll see you next time.